It's my pleasure and honor to be here, engaging with the ecosystem in Greece. It's also my first time to visit Greece, beautiful country. So I look forward to doing some sightseeing, after this conference. So again, we're going to talk about a very interesting topic today. I've been in the industry about 20 odd years. The pace of innovation that's been happening in the last 3 to 5 years in technology is just fascinating, right? We really live in exciting times, especially when it comes to AI and machine learning. There's a lot of hype around generative AI, right? We hear about all the disruptions being caused by transformers and foundation models in terms of generating, text, videos, images, and the consumerization of that, which is really hyped up. But what I am personally, and a lot of us at Renesas are really excited about, is the magic that's happening at the other end of the spectrum, which is the far edge of the spectrum. The AI and machine learning that's being implemented in tiny microcontrollers and compute devices that is running locally, doing local inferencing, local classification, local regression, to basically offer very important information for overall IoT implementations. So that's what we're going to talk about today as part of this discussion. Tom covered some of this, so let me just talk about it, right? In the end, for anything to be done with machine learning or AI, it's all about the data. And it's literally a data explosion when it comes to IoT. About 85% growth year on year for data that's being created by IoT devices, right? This is significant growth in data creation. By 2025, we have about 80 zettabytes of data that's going to be generated by IoT devices in that single year, right? I think Tom said about 570 zettabytes by 2030. So it's fascinating in terms of the amount of data that's being generated. And I had to actually look it up. Zeta has 21 zeros, right? So it's just fascinating how much data is being generated by IoT devices. Another interesting statistic here is a lot of this data historically gets piped up to the cloud mindlessly, and it essentially sits in an enterprise data center. It's dark data. Pretty much 90% of this data never gets used for any real applications, right? And this is how it's been historically, because this is where the data concentration is, this is where the intelligence concentration has been. It's all been concentrated in the cloud and the core of the network. And let's talk about how that's going to transform and how that's going to change and what's happening in that space. Okay, I call this the perfect alignment of stars, right? So AIoT is the marriage between AI and IoT. Stands for Artificial Intelligence of Things. And really what's driving this trend, this mega trend, is multiple underlying trends, right? We have a real powerful convergence between 3 technologies: IoT, AI, and 5G, which are roughly maturing at the same time, right? This is going to really create a big boom in terms of data creation, connectivity, all of those things. Decentralization of intelligence, right? There are tremendous benefits of decentralizing intelligence. And we'll talk a little bit about that, right? There are real sustainability concerns when it comes to generative AI. I've read articles where, every 20 queries that you put in ChatGPT is equivalent to taking 22 ounces of water. This is actual data from Microsoft Data Center from Idaho, right? It literally not only consumes power, it consumes 22 ounces of water when you do 20 prompts and 20 queries inside ChatGPT, right? That's fascinating. It's just not scalable in the way it is currently set up, right? And eventually we have to figure out how to scale that. We already talked about the data explosion. And the fourth thing is just a new design mindset. Renesas has, in the order of about 30 to 40,000 customers globally, big and small. So we see a broad spectrum of applications that our products are designed into. We're getting asked by customers in pretty much any end application, and everybody's thinking about how do we leverage AI and machine learning for problem solving. And that's essentially what we're seeing is basically AI and machine learning being applied to system level problems, to solve system level problems. So the design mindset in this space is shifting in terms of thinking about AI and machine learning and applying AI and machine learning to their systems. Okay, let's talk a little bit about decentralizing intelligence. Why should we decentralize intelligence? I mean, if you think about the far edge of the network, right? I mean, typically when intelligence was concentrated all in the cloud and the core of the network, any query that had to be made or any machine learning algorithm that was running would have to make a query up to the cloud and then wait for the round trip response time back. Now, for certain applications where humans are involved, a few seconds of response time might be tolerable. But now think about machine-based applications in the industrial space, right? Some of these applications are real-time, some of these applications are mission-critical, some of these applications are life-critical. So, and a lot of these applications cannot tolerate a round-trip time to the cloud for every query, so localization of the processing and localization of the intelligence is significantly important. So that's where the real-time response comes in, and that's where one of the key advantages of decentralizing intelligence is providing real-time response. We heard a lot about security, so by no means I plan on covering that, but essentially what I'm saying here is because you're doing a lot of localized inferencing and localized computing, the amount of data that you need to pipe up to the cloud is significantly less, right? So you're literally reducing your data in flight or data in motion security posture, and it's essentially better, and even from a privacy standpoint, because you don't need to transport data through the network to make certain decisions. The other thing is, I think Tom talked about this, a lot of these compute devices now have root of trust, right? And all of the AI and machine learning and local processing that happens on these devices can be tightly coupled with the hardware root of trust on the device. And anything that needs to get sent up can be sent up using a public key infrastructure or a certificate-based infrastructure, using a digital signature. And thirdly, there's this concept of data gravity, right? I mean, these devices that are sensing things around us that we interact with on a day-to-day basis are essentially the closest devices to the data. So we're actually leveraging the power of data gravity by processing data at the point at which it is being sensed or ingested by the device. This also helps reduce transport. It helps reduce, it helps improve efficiencies of the network because you're not constantly turning on and off radios and sending data back and forth between different layers of the network, right? So it essentially, from a decentralization standpoint, you have real-time response as an advantage. You have, improved data security and privacy because you're not, sending enough data across the network. And thirdly, you have a better agility overall from a network operations standpoint. Okay, let's talk a little bit about mindset, right? If you think about any IoT device or any IoT system for any of these end applications, right? Whether it's healthcare, home automation, infrastructure, industrial automation, it's essentially a combination of core technologies that have to come together at a system level. And those key technologies are listed on the right. Sensor fusion, motor control in some cases, human-to-machine interaction, connectivity, touch, cloud connectivity, functional safety, robotics, IoT security, et cetera, right? Essentially, when you're designing a product or an IoT system, you're thinking about how you combine one or more of these key technologies to realize your end application. AI, on the other hand, is a little bit different. AI is more like a horizontal enabler across these things. AI is not necessarily a core technology. It essentially bridges these core technologies to these end applications, right? AI and machine learning can be used to solve, it can be used to enhance aspects of IoT systems that might be related to maintenance, effectiveness, liability, personalization, safety, security, and much more, right? So essentially, we're thinking about applying AI and machine learning to solve fundamental system-level problems. So it's much broader than saying that AI and machine learning is just a key technology. It's actually a bridge that bridges a lot of these key technologies to the end application. I mean, the impact of AI on our lives is more visible than ever, right? These are just some visuals of applications that we don't even think about. These are, far edge applications, whether it's a robotic arm, whether it's a thermostat in your house, whether it's a, brushless DC motor that's running inside your washing machine, whether it's a blood glucose monitor, et cetera, et cetera. All of these, in many ways, are running AI and machine learning, and if not, people are thinking about implementing AI and machine learning in these end applications. So let me talk a little bit about Renesas and how we are addressing, this market, right? So Renesas has a broad portfolio of products that go into IoT and AIoT applications. We classify our products broadly into sense, movement and storage of data, which is essentially connectivity, compute, and actuation, right? And these are some of the core semiconductor components that go into building pretty much any system. On top of this, we offer a comprehensive portfolio of AI and machine learning tools and solutions, right? One of the challenges that we see in the AI and machine learning space when it comes to embedded is today the embedded domain and the machine learning domain are two disparate domains. Typically when you're designing an embedded system, you're using an IDE that's essentially local to your machine. And when you're working with an automated machine learning environment, it's typically something that's cloud-based, that's doing your ML ops flow for you, right? The problem today is these two don't talk to each other. What Renesas is doing, and again, the industry at large is far away from where we need to be. What we're doing is taking steps to basically bring these two domains closer to each other, right? Last year, we acquired a company called Reality AI that essentially brings an AutoML workflow for real-time analytics within our portfolio. And what we've done is now we have a context-aware API exchange between the IDE and the auto machine learning flow so that people can exchange models and project information seamlessly between these two developer environments. Now, depending on which type of data you're starting with, whether you're starting with sensor or signal conditioning data, you're starting with just simple use case requirements. Some customers like to bring their own model, or they have a pre-trained model that they want to pick. And some customers, when they're working with voice, might want to start with voice commands. Depending on what the starting point is, it's some form of data, whether it's voice data or vision data or sensor data. We have a whole portfolio of tools that you can go through in order to accomplish your end application. Let's talk about some practical examples of where we see AI and ML in the industrial applications. And again, by no means this is comprehensive, right? We have, we've implemented machine learning in a vast variety of end applications. One of the things that we've seen a lot of traction on is voice. And this is local voice. This is not voice. This is not your Alexa and Siris that essentially go up to the cloud and do the cloud-based querying. These are local commands that can be embedded inside devices with local processing. So you can essentially talk to your IoT devices, right? We have an entire software suite that supports 44 different languages, right? So you can essentially enable complete command-based communication with IoT devices. And obviously, these language models are deep learning models, right? These are all foundation models that are based on deep learning techniques. So voice is one of the leading areas of application of machine learning at the edge, and we continue to see strength in this space. In fact, what happened with COVID is we started seeing the request for voice being integrated into applications we didn't think about before. In a lot of industrial applications, people wanted to start putting voice in there, right? Because it's a great non-contact based communication technique from human to machine communication. Machine personalization is another big area, right? So for example, you could use multiple modalities of machine learning, combination of voice and vision. You could be detecting a human based on voice signatures as well as face recognition, and then personalize a machine or provide authenticated access to a particular machine based on multiple modalities of machine learning and AI. So here's another application where we've actually taken 4 or 5 different deep learning models and embedded them on a Cortex M4 class device, right? This is a device that's running 200 megahertz with about half a megabyte of flash, right? So it's a very, very constrained device. And it's essentially, you can use it to provide authenticated access to, say, a factory floor machine, or you can say if you're in a house and if you have machine learning in your induction oven, but you don't want your kids to be able to operate it, it could even personalize the oven and have a safety shut-off feature if somebody who's not authorized to access it is accessing it. We've done some interesting things in the HVAC space, right? This is with predictive maintenance. So for example, another application is how do you create a self-sustaining, self-healing, predictive maintenance-based approach for things that use, for things that have that are used in like HVAC systems or things that are used in refrigeration systems. So this particular solution has the ability to detect multiple anomalies, things like refrigerant leaks, things like whether there are any other issues, demand ventilation from HVAC perspective. So that's just another application where we've been able to implement machine learning in another application. And again, vision is a huge space, right? So typically what we see from customers is because vision is such a data-intensive application, a lot of customers look for pre-trained foundation models that they can just retrain using incremental data, significantly reducing their time to market. It's all about ecosystems, right? Renesas has a very large ecosystem from an IoT perspective, and this continues to grow, right? And I believe from an industry standpoint, it's very, very critical for pretty much all large semiconductor companies or tech companies to have large ecosystems. Our partners is what basically makes us stronger and provides customers with options when it comes to working and building IoT systems. So I'll close. In summary, right? I think the convergence of AI and IoT is just a megatrend that cannot be ignored. There's just tremendous amount of applications of localized inferencing, classification, regression, anomaly detection that can be applied to these devices at the extreme edge. Explosive growth in endpoint data creation. Decentralized architecture there is going to unlock a lot of potential. Talk to us. We've got a tremendous offering of hardware, software tools, and ecosystem. We've got a local team here in Greece that can support you. Please check out renesas.com/AI. We've got a lot of educational resources there. Come talk to us about your next IoT challenge. So thank you.